Alright, in this video we're going to do an example of solving an equation using our double angle identities. And here are our double angle identities. For sine of 2x, there's just one. It says it's 2 sine x times cosine x. But for cosine of 2x, there's actually three. There's 2 cosine squared x minus 1, 1 minus 2 sine squared x, and then cosine squared x minus sine squared x. So in this case, I'm going to solve, we'll do part A here. We're going to solve cosine of 4x minus 3 cosine of 2x equals 4. Okay, so, if I saw a problem like this just out of nowhere, the first thing I would kind of think is, maybe I can somehow at least make the sort of the insides the same. Instead of having 4x and 2x, maybe we can make them a little more similar. And what I'm going to do is I'm going to rewrite cosine of 4x. So cosine of 4x, I can really break that apart using our identity. So to me, the way I kind of think about this identity, and there's three to use here, but our original problem only had cosines, so I'm going to pick the first one just to keep everything involving cosines. So to me, the identity says, well, you pull a 2 out, and then you take cosine squared. Inside the parentheses, it says, whatever you had before, so we had 2x, it says you take half of that, and we just get 1x. Well, now we've got 4x on the inside, so if we take half of that, it'll actually reduce down to just 2x minus 1. And there's our identity now. Alright, so we'll just fill that in then. So here's our identity that we're using. So it says cosine of 4x, I'm going to write, well, 2 cosine squared of 2x minus 1. And then we still have our minus 3 cosine of 2x. What I'm going to do is I'm going to subtract the 4 over to the left side as well. Because in general, to solve equations, a lot of equations, what you simply try to do is make one side 0 and factor. So hopefully this will factor somewhat nicely. If not, it's going to be a quadratic in cosine of 2x. And we've seen how to use the quadratic formula to solve trig equations. So if nothing else, I'm thinking, well, if I have to as a last resort, I can always use the quadratic formula. So let's see, we've got negative 1 and negative 4, which is going to be negative 5 equals 0. Let's see if we can't get this to factor a little bit. So I'm going to have a 2 cosine of 2x, and then I'm going to have another cosine of 2x. Because when I distribute these out, well, I'll get my 2 cosine of 2x times cosine of 2x will give me my cosine squared. Let's see, so I need numbers on the outside. They have to multiply to 5, but somehow I'm going to have to get a negative 3 in the middle. I think if we use negative 5 here and positive 1 here, I believe this is going to factor correctly. So if we distribute, and you can always write this all out, we'll get 2 cosine squared of 2x. We'll get a positive 2 cosine 2x, but then we'll get a minus 5 cosine of 2x, which will give us our negative 3 cosine of 2x, and then we'll get our negative 5. So, hey, this looks like a correct factorization to me. What we're going to do now is we'll take each factor and set it equal to 0. So 2 cosine of 2x minus 5 equals 0. Let's see, I'm going to add 5 to both sides, so that'll move the 5 over. And then we can divide by 2. So we would get cosine of 2x equals 5 over 2. Let's think about this equation for a second, though. Cosine of anything, cosine of anything has to be between positive 1 and negative 1. That's the range of cosine. 5 halves, though, that equals 2.5. So 2.5 is outside of the range of cosine. And that simply says that this equation is going to have no solutions. Alright, well, at least that makes work a little easy for us. Now we'll also have to take cosine of 2x plus 1 equals 0. So let's see, that'll be cosine of 2x equals negative 1. Okay, so now I'm going to start thinking about, my original interval, I think we said we'll find solutions in the interval 0 to 2 pi. So I'm going to do like we've seen in some of the other examples, just to make sure that I get all the solutions. So we want to solve, so really the whole problem now has come down to solving cosine of 2x equals negative 1. And again, x we want it to be in the interval 0 to 2 pi. Well, what I'm going to do is I'm simply going to let y equal 2x. Well then, if y equals 2x, since x was in 0 to 2 pi, 2x would be in the interval 0 to 4 pi. I'm just doubling. So equivalently, that means y, we're going to find all solutions to the trig equation cosine of y equals negative 1. But again, we want y to be in the interval 0 to 4 pi. Well, let's see, in terms of the unit circle, let's see, cosine of pi equals negative 1. So y equals pi would be a solution. And then let's see, I think the next solution we would get would be at 3 pi. And that would be all the solutions in the interval from 0 to 4 pi. But, well, y was the same thing we said as 2x. So either 2x has to equal pi, or 2x is going to have to equal, whoops, I wrote 2 pi, or 2x is going to have to equal 3 pi. Well, each one of these is, these are easy to solve. Just divide by 2. We'll get x equals pi over 2 as a solution to the first one. We'll get x equals 3 pi over 2 for our second equation. And those are going to be our two solutions to this very original equation, wherever it's now disappeared to. So it says the solutions to cosine of 4x minus 3 cosine of 2x equals 4. It says our two solutions are going to be x equals pi over 2 and x equals 3 pi over 2. Those will be the only two solutions in the interval 0 to 2 pi.